we'll be looking at a few examples to solidify what we've learned in this analytical geometry section. So our first example, the gradient of CD is equal to 2, and they tell you that C is negative 1 and 0 and D is 1 and Y. So we don't know the coordinate, the Y coordinate of D. And the question says calculate Y. So if we know the gradient and we have one point and another partial point, we can say, well, the gradient formula is M, right, of CD is equal to Y2 minus Y1 over X2 minus X1. Now I know the gradient is 2, so I'm going to fill in 2 on the left hand side is equal to, let's make that X1, Y1, X2 and Y2. So for Y2 I'll substitute Y minus my Y1 is 0 over X2 which is 1 minus my X1 which is negative 1. Right? So Y minus 0, that's just Y over 1 plus 1 is equal to 2 on that side. Okay, let's take it over this side. 2 is equal to Y over 1 plus 1 is 2. Now I want to get Y by itself. So I'll times by 2 on both sides. 2 times 2 is 4. These 2's cancel. Therefore, Y is equal to 4. Example 2. Find the equation of EF if E is negative 6 and 1 and F is 0 and 3. So the equation of a straight line is Y is equal to mx plus C. Now we don't know the gradient, so we are going to need to determine what the gradient is, and C is our y-intercept, right? Now our y-intercept is always 0 and the y value. And if you look at these two coordinates, you can see that F would then be our y-intercept, which means that C would be equal to 3. Okay, let's look at our gradient. So the gradient is equal to y2 minus y1 over x2 minus X1. Y2, 1 minus Y1, which is 3, over negative 6 minus 0. 1 minus 3 is negative 2. Negative 6 minus 0 is negative 6. So, therefore, my gradient is equal to negative 2 over negative 6, which can be simplified to 1 over 3. Okay, now let's fill in what we know into our standard equation. So I have y is equal to, my gradient is 1 over 3x plus my y-intercept, which they gave me, is 3. Now B, which is our second part, asks us to determine the equation of line AB if AB is parallel to EF and it passes through the point Y, which is 6 and 1. Now, if these two lines are parallel to each other, that means that their gradients are equal. So the gradient of EF is equal to the gradient of AB, which is equal to a third. Okay, now we have a gradient and we have another point on this line. So we're going to have to substitute this point into our standard equation in order to find the y-intercept, because we weren't given the y-intercept of line AB. Okay, so let's do that. Okay. I have y is equal to mx plus c, and we said our gradient is a third. Now we're going to substitute our point y, which was 6 and 1. So my x value is 6 times by 6. My y value is 1 plus c is my unknown. 1 is equal to a third times 6 is 2 plus c. So 1 minus 2 is equal to c, therefore c is equal to negative 1. So the equation of line AB then is y is equal to a third x minus 1.